Okay, here's a question. Draw the Lewis structure for the azide ion. Azide is a great antimicrobial, even though it is somewhat poisonous to us too. So draw the Lewis structure for the azide ion. Okay, let's go over here and let's go ahead and do that. So the azide ion, let's count out the number of valence electrons. I have 3 nitrogens. Each of those have 5 valence electrons. And it's going to equal 15 valence electrons I have to take care of. And then we have that 1 negative charge right there, so that will equal 16 valence electrons. Okay, they're all nitrogen, so let's just go ahead and draw those and connect them first. Nitrogen, nitrogen, nitrogen. So I've used up 4 valence electrons, so I need 12 to fill this out. Well, typically what we do is we add lone pairs to those terminal atoms, and so let's go ahead and do that. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so let's go ahead and count up the electrons that I've added. So I've got 2, 4, 6, 8, 10, 12, 14, 16. So I've done that part. I've got the right number of valence electrons, 16. Let's look at octet rules here. So this nitrogen right here has 2, 4, 6, 8. So that one's happy. This other nitrogen on the right hand side has 2, 4, 6, 8. So we're good there. But look at that middle nitrogen. That only has 2, 4. It needs 4 more valence electrons in order to make it an octet. What we can do is we can take this lone pair and move that over to that bond, take this lone pair and move it there. And now I have a new Lewis structure. So I have nitrogen, nitrogen double bonded. And then I have nitrogen double bonded again. And then I have 2 lone pairs left over. 2 lone pairs, 2 lone pairs. Alright, let's look at this new Lewis dot structure. I have 2, 4, 6, 8, 10, 12, 14, 16. I still have 16 valence electrons, so I'm good there. If I look at the octet rule, I have 2, 4, 6, 8. Surrounding that left nitrogen. In the middle I have 2, 4, 6, 8. That fulfills the octet rule there. And on this one on the right I have 2, 4, 6, 8. Since this is an ion, we usually put that in brackets. In brackets. Put a minus charge. This here is a valid Lewis dot structure. So let's go ahead and go back to Alex itself. And let's put it in there. Okay, so go back to Alex. I got nitrogen bound to another nitrogen bound to another nitrogen. Okay, if you remember, we had these as double bonds. Okay, and then we have lone pairs, 2 over here and 2 over here. This then is going to put into brackets. It's going to be a minus charge. So this, my friends, is the azide ion correct Lewis dot structure.